Thank you. My talk is about Entangled. Um, I'm working at the Netherlands eScience Center that's located in Amsterdam. At the eScience Center, we work with scientists all over the Netherlands from all disciplines, and our main focus is to improve the usability, reusability, reproducibility, and all the quality aspects of the software that is being used in scientific domains. So, yeah, it's a bit of a broad scope title. But the idea is that I will present you with kind of a workflow of how we can do science. Let me switch tabs here. So this is quite recent. This is work that I did I think 2 weeks ago. I started this. We have a model, and this is about sedimentation in seas, and we needed to implement some transport model in this. So you have some documentation. This is a Pluto notebook. Anyone not familiar with Pluto here? Okay, awesome. I love Pluto. So it's really great, and it allows you to put documentation in between your code, and in this way establish a human readable narrative next to where you start to implement this code. And what I think is important to understand here is that we're not just programming for the computer to do things, but we're programming also for our colleagues to understand what we're doing. And in this case, this is a very direct communication between me and the lead investigator of this project. So say, this is my shot at the transport model for our model, and what do you think about this? So there's some testing in here, and then here at the end you see that okay, some matter is being transported, and it's being produced at the same time. So it's wonderful. But now we want to go to the next stage. I want to put this kind of a proof of concept of this model and put it into the larger code base of the model, which is a Julia package, but I want to retain all the nice properties that I have from the literate programming. So I will immediately present you with the result. And show like, okay, we can do this. This is Documenter.jl. Everyone is here familiar with Documenter? Cool. So this is all typed in Markdown. I add some nice figures to illustrate the concepts, and then we basically get the same code again. This time, all my code is in Markdown code blocks, and I give them names. So you see here that I added a little tag saying, okay, this code block is example active layer, and here we have a file, source transport active layer. This is actually a module, and I can continue with the previous code block. So I don't need to put everything in order. All of the code can be wherever you want it to be to give you an optimal narrative from a human perspective. And this is the original idea of literate programming as it was first invented in the 1980s by Donald Knuth, who is the grandfather of a lot of domains in computer science and also with literate programming. You see the same plots here, but now these plots are actually being generated using code that is now somewhere statically inside a Markdown document. And I add here some commands that is being parsed by a component that turns this into a workflow. So not only is this being plotted, but it's being stored. So I don't need to recompute things twice. It's just done once until the code changes. So for example, there's requires, which means if this file changes, then also update the plot. Okay, so now the question is, how does this work? I gave you a little bit of a science story. We moved from a Pluto notebook or a Jupyter notebook to code that's just based into Markdown. How does this work? And the magic behind this is what is Entangled. So Entangled, no one can be told what Entangled actually is. I will show you. If this works. Just this morning this worked. Okay, I will. I am not online, am I? Yeah, apologies for this. Internet. Can I have internet? Oh, there's my internet. Sorry, I just put up a hotspot. There we are. Yeah. So this is an editor where you have, in this case, Vim. It can be any editor. And here you see I have the Entangled daemon running. This example is in Python. Entangled works in any programming language. So if you have a Fortran project lying around and you want to do literate programming in Fortran, you can do it. In this case, it's Python. So you see that automatically this file is being created because we put it here in the Markdown metadata. And you can decompose the program into different code blocks. You give them names like this. You say hash factorial. Now this code block is named factorial. And then refer them to them in other code blocks, and the order doesn't matter. So now using these, this is no web notation. This is also, I didn't invent that. It's from the 90s, I think. Okay, now there's an error. What do? We don't want to debug from a Markdown file. That's just terrible. So we open up the Python file that was generated and start to edit in there. And now you see that I fixed all the errors. And you see that those changes were actually propagated back to the Markdown. So, thank you. So this means that we can still have all the facilities that we're used to from the IDE. The syntax highlighting, everything just works. You can develop like you're used to, fix bugs like you're used to, but you don't have to do it in Markdown. So this, unfortunately, this is a Python module. I would love to have this as a nice binary package. I don't know, but so you'll have to stick with pip for this one. But you can use it with any language that you like. And last slide. So Entangled.github.io, very easy to remember. There's some information there. You can rewatch this animation if you like. If you want to contact me, this is my email.
Okay, thank you very much. Very nice presentation. I would take also the chance to clap the hands for the presentation of Surya that we forgot before. Okay, so questions for Johan.
Yeah.
Any question?
Yeah.
Okay, we have one there.
Hello. Hi. So you made the Documenter website with Entangled, right?
Yes.
Cool.
Well, so I actually had to hack a little bit into Documenter. So if you're interested, I can show you. I had to transpile the Markdown to a second version of to a second Markdown version, and then compile it by Documenter. Yeah.
How does this compare to Emacs org mode?
Org mode is terrific. I've tried it for half a year or so. It's really nice, but it only works in Emacs. I mean, I know that there's a VS Code mode for org mode, but it's not quite there yet. So if you do this in org mode, you force all your collaborators to use Emacs. Also, org mode doesn't have this reverse capability where you start to hack into the files that are generated and then translate them back.
Any other questions? Okay, let's thanks again, Johan.